Hey everybody. So in this video, they ask us to find the value of 2x. So it says, if cotangent of x is 7/13 and angle x lies in the first quadrant, find the exact value of cosine of 2x. One thing we need to realize is that cotangent is the adjacent over the opposite leg. So what we'll do is go ahead and put 7 as our adjacent, and we'll go ahead and put 13 as our opposite. So you'll see that we are missing this leg here, this hypotenuse. So what we're going to have to do is Pythagorean's theorem. So we'll set it up like this. So in order to solve for c, we need to take the square root of both sides. And this is going to give us the square root of 218. So we'll put that along our hypotenuse. Now that we have all the ratios, we can go ahead and plug in the ratio for cosine of 2 theta. So we need cosine squared minus sine squared. So cosine squared is going to be the adjacent over the hypotenuse, which is 7 over the square root of 218. Sine squared would be the opposite over the hypotenuse, so 13 over the square root of 218. So when I square these fractions, the numerator will be squared and the square root will go away from the denominator. So now I can subtract 169 from 49, and that will give me negative 120 over 218. So when I simplify this fraction, I'll get negative 60 over 109, and that will be the value of this angle. Now I know that this may be a problem or a little bit confusing because it says that it's in the first quadrant. Well, that's the angle that's in the first quadrant. What they want you to do is double this angle. So you have to think, let's say if you already have 13 and 7, your opposite and your adjacent, what if you did inverse tangent of that? So if I did inverse tangent of 13 over 7, I'm going to get about 61 degrees. So if you double that angle, you're now at 122 degrees, which means that you're in quadrant 2, which is why your x value here, cosine of the angle, would be negative. All right, I hope this helps. If you have any questions, please make sure you leave them in the comments, and we'll see you all in the next video.